Hello, everyone. Uh, we'll wait for another 2 minutes and then we can start. Feel free to message in the chat, like if you have any queries, anything like to discuss. So we'll just wait for 2 more minutes and then we'll go to start. Hope my voice is clear and anyone having trouble in yeah, okay. Thank you. Camera on. Yeah. Okay, so maybe we can start, and we'll see that as people will join, we'll keep on admitting them. So first of all, hello everyone. A big warm welcome to all of you, like students, engineers, innovators, and curious minds. Today we are actually kicking a kickoff. It's a kickoff session of modern intelligent system design, and it's about actually beginning of reviving the UT Dallas computer science outreach community. Right? So basically, Alex, 1 second. Okay, so let me know whenever if you have any queries, please feel free to reach out. In this entire presentation, in this entire session, it will be divided into 30 minutes of discussions, like a presentation, what our vision is with this community, and we are open to take up more and more different type of sessions based on the demand. And the second part will be entire discussions that, okay, what's your questions, and we're happy to answer, right? So I can see that some of the folks are joining. So yeah, sorry for 1 or 2 minutes of delay. But yes, we can start. So let's get started, right? Basically, how this actually. Let's get started with a brief story about the evolution about AI, right? usually like I don't always whenever I think of artificial intelligence, it's not exactly I think about AI, I think of intelligent systems, right? Just a quick question to all of you who joined this session, right? What like we started with like writing on the leaves, then papers, typewriters, computers, applications, mobile apps, right? All these things happened, the evolution happened. But one thing was always common. So can anyone of you can just drop a message that what was the common thing between like from the age of writing over the leaves till like doing it like putting it over the mobile apps, writing over the mobile apps. Like, can anyone like to answer or just drop a message? What is the similarity between it? Anyone? Well, just to answer that, uh, actually, like yes, like yes, right, correct. All of you are correct, right? Yes, absolutely. And for right, need to capture, transfer data, information exchange, goals to communicate, programming. Yes, yes, everyone is correct. At a high level, just if I go, like it's more about basically whether we are transferring the data, we are communicating it, right? It's like a basically a crude operation. Basically, we are creating the data, we are reading the data, we are updating it, deleting it, right? That's the kind of things, and we are of course exchanging the information between folks, right? But one of the thing is like I can start with my own story. Like 4 years back, I was like sitting at a system, and when because I'm like worked on like entire distributed architectures. Like I will walk you through who I am, so that will actually give us a brief about myself. But like over 15 years of experience in a lab before like 4 years back, I was sitting like late night at my system and like and thinking that okay, at the end of the day, I'm just developing a system that is doing create, update, modify, and remove, and maybe, of course, right? This is all the thing I'm doing since last many years, more than a decade. But the problem is that now it's an arena of making the system intelligent. Wh- I know sometimes the AI word, I always feel like it's overused. I like saying it as a intelligent systems, right? I started thinking in a direction that okay, why let's try to make the systems intelligent rather than like doing the same operations again and again. No matter we are working from a single monolithic application till microservices till distributed architectures, at the end of the day, we are just doing the same thing. But now from the past couple of years, now we are actually moving towards a different direction. We just don't want to create update crude typical crude don't want to do just crude operation. We want to create the intelligent systems so that they can actually take a lead, they can actually work like us, like they can a system that can think as well. Then after that, then I started designing the systems. Like one of the systems that first I designed was in a financial institution that can actually with machine learning, it can actually find out the regulatory issues in the data based on certain parameters and from the past data sets. So that was like one of my first project where I was able to detect the regulatory issues, and because that in a financial institution, regulatory issues causes billions of penalties. And then I came up with the approach that okay, let's use the machine learning approach in order to identify the regulatory issues from the based on the data from the parameters. Of course, it was a combination of supervised learning as and unsupervised learning. But on top of it, I went on and created a system, and that was one of the like the first systems in that financial institutions who actually they were able to capture the regulatories, and we were able to save millions of dollars in that system, right? Moving towards our goal, what who we are, right? Let's start with myself, a bit about me. My name is Nishit Singh. I'm a full stack architect, like a developer, right? Who has like worked on like mostly from a Java background, then moving towards the Python, then generative AIs, right? Like worked on different systems for the past 6 7 years. I'm working on most of the financial BFSI domain, like mostly interacting with the financial systems. And before that, I have an experience working with the social networking platforms and like income, like another like income tax related systems, and of course, so the ERP, human resource management. So and also like the inventory management system using RFID technology, where like I got a chance to create my own analytics. So I had a chance to work on very interesting projects, and like that gave me lots of ideas. Okay, just to move away from the traditional based systems and moving towards more intelligent based systems that we call it as an artificial intelligence in today's arena, right? So so that is a brief about me. I'm like I'm a, in terms of education, I'm a master's from Birla Institute of Technology and Science, and that's an institute based out in India. And had a chance to like and that is my some of my like certifications, like when it comes to, so I'm a certified cloud architect, a machine learning and professional machine learning engineer, right? And I had a chance to work on some of the projects, that is, these are them, like chat-based personal AI systems, Gen AI, chatbot for the financial institutions, some of them. And then I sort of creating an entire community, that is AI DevWorks, that will actually cater not only our complete education, complete research and development community. And then I started with that, AI DevWorks. Right. So this is a brief about myself. I'd like to just have a quick understanding that how many of you are like from the students background, and so how many of you are professional? Just a couple of them. Who are? Can you just raise your hand and let's just plus one, that how many of our students and how many of like very experienced professional? Just some of you, like if you're okay, right? So that yeah, please go ahead. Yeah, Shri- Sridhar. Okay, that's good. 10 years full stack engineer, right? That's good, right? So starting with how many? Yeah, 2 years full stack. Okay. Okay. So that's good. Actually, we have a variety. So please feel free to ask your questions. We'll in next at least 30 minutes, we'll go through the slides about our goals, of the goals, and then about this community, how we are reviving this community, and then we'll move towards that how about the questions, and we can discuss like we'll open the platform for discussions, right? So this so let's start with our mission. Like our mission is to learn together, collaborate, innovate. If you go to our site aidevworks.com, right, you will see that we are coming up with we have like multiple past meetups that we have done, right? And apart from that, we are also coming up, we have resources, so we are increasing it. We have a target of increasing till 1000 by the end of this year, that is just next month, right? Apart from that, we are also like launching a platform called Nishai, that's very similar to our open API, but it's of course a child of it. We are trying to raise a phase one of it. That is a LLM. So this is a multi-model intelligence, smart query routing, lightning fast responses. So this is a platform we are planning to launch by the end of this year, right? So this is a brief about AI DevWorks. About if I go to the AI DevWorks, you can find all the lots of resources on this platform, right? Another thing is that we will make sure that all the workshops that we are going to host is absolutely free. We are never going to charge anyone of the AI DevWorks community organizers will never going to charge anyone. It's completely free. We'll be using some third-party tools, but it's up to you that if you like to use those tools or not. Once our platform is out, then you can possibly use those platform in for during those workshops in order to do your practice and on, right? So that is our vision, so that we can actually will learn together. Soon we'll be getting into the cohort where we are actually creating those workshops, and we'll create different projects. So maybe once in every quarter we'll try to have some sessions, right? Especially where we'll be asking some of the folks to design a product, and we'll help them to design a product. So usually so we have multiple like plans for this community, and for this Dallas reviving this group, right? So in this session, topics that we will cover is understanding modern AI architecture layers, how LLM, vector, DB, RAG work together, role of embeddings and retrieval, and next step for AI projects and learning path, right? So please feel free to just message wherever I go fast, or like if you're having like if there's anyone has a problem in like understanding, right? If I'm not clear enough, please feel free to message in a group. And so next 30 minutes, like it's already so we'll spend on this, right? Let's start with so usually I always believe that starting off any new things, right? Even if you are experienced or not experienced, right? It's always good to start with at least some basics, no matter you will get into the deeper into it or not, it doesn't matter. But still it gives you a chance to explore, to understand why we are doing these things, right? Some of us actually in this group may just want to uh, consume this API, right? Some of you may be a developer of LLMs. Some of you want to design like a complete RAG-based systems. This community is going to cater all three type of users who just so that it will be value additions for all of you, right? So let's start with our AI fundamentals, right? So AI, understanding the foundation of artificial intelligence. Let's go to first towards the machine learning. I could have started from the data analytics, but I thought to start with machine learning, so that, and we'll try to use it very layman terms, so that even if you are not experienced enough, you can still try to connect, right? Let's talk about the machine learning. When we talk about the machine learning is actually about building a system that learn patterns from data and make decisions without being explicitly programmed, right? That's a typical definition, right? So there are different ways. Like for example, there are different type of algorithms. Like so, it already have some data sets, and it is trying to learn from them. That's machine learning, right? It is not trying to generate its own data sets like a generative AI. It's just about learning from what patterns that already have. Right? At a high level, there are basically three types of learnings. How we in machine, that is supervised learning, unsupervised learning, and reinforcement learning. I will try to go a bit fast, so wherever let me please stop me. In supervised learning, right? It's about learning from labels. So I will just give an example. Like for example, if we say you might have heard about spam detection emails. That is one of the very popular model, right, in machine learning, right? So like in if we talk about the spam detections, right, what we do like in emails, whether it's a spam or it's not a spam, how the machine learning identifies it, right? It is a kind of part of the supervised, it's kind of comes under the supervised learning when we talk about the spam detections. Like of course there are different ways of it, but one of them is of course popular ways is spam supervised learning, where we actually, for example, you won $1 million, right? And there's already a trained data sets where they have different set of data and labeled the data. So there's already labeled whether it's this kind of a message. For example, you won $1 million in an email, and it is already identified as spam, right? So these kind of things actually, we actually use this kind of a data sets that, okay, just another example, maybe like meeting at 2 p.m. today, right? So it's not a spam. So we have actually created a supervised learning data sets on which it is trained this machine learning that, okay, whether it can be spam or not spam. And then based on that, it actually use those basically use those weightages in order to set against those attributes, so that it can use those existing labels, right, existing trained data sets, in order to predict whether this particular new email that is coming, right, that is a spam or not. But in supervised learning, everything it's labeled, like it's labeled, right? It's not like it is not need it as it doesn't it already have a data sets that has a labeled data sets, right? Moving on to the second type is unsupervised learning. When we talk about the unsupervised learning, right, it's like learning patterns from unlabeled data. uh, let me give you an example, right? For example, like I go to a Walmart, and like there are lots of people, right, and they try to buy lots of things, right? And now, if I have to categorize the data based on their buying way, and analyze how they are buying the products, right, then based on that, actually we can actually start clustering, or grouping the set of users, grouping the set of attributes, right, and then start labeling them. So for example, like there's could be cluster A that is buying a baby products, there could be cluster B that is buying electronics, there could be cluster C that buys fitness gears, right? So we can always group that users, that for example, if the buys a baby products, then of course there are the parents, right? So based on that, we can actually trying to label them, label the unlabeled data, basically grouping them, right? So this is one of the examples, and there was one of the, like a supermarket did an analysis, right? Very popular theory. There were a particular. Let me talk about the scenario. They identified that, you might have noticed, they identified that during the holidays, during the weekends, whenever especially the youngsters who's they were buying beer and the baby napkins together. That was a very interesting analysis that was done by the supermarket. And but the point is, there's no relation between the buying a beer and the baby products, right? But they kind of, based on the buying people buying those products, they identified that during the weekends, especially the people of age 25 to 35, right? Okay, just tentatively, they're buying the beer, like the cocktails and the baby products. Then they derived a conclusion that, okay, basically, like during the weekends, especially when the holidays are there or when the weekends are there, the people who are like newly married or has a very young baby, right, they buy those products. They want to chill out, right? They want to chill out, and that's why they go for cocktails. They buy those beers and like a different type of cocktails, right? But they have a small baby as well, so like, of course, and so the baby, of course, there could be like baby products. I mean, they need to get the napkins, the diapers, and all. So they need to buy the same, because they need to take care of the babies as well during the weekends, right? So they actually put the cocktail and the baby products next to each other, right? The counter, actually they kept next to each other, and the sale actually increased considerably. That was one of the analysis that is one of the supermarket at did. So that was one of the, if you go and search in Google, you will find that easily, right? So you can think of how they actually ended up in this. This is one of the good examples of unsupervised learning with real life case studies, right? So that's the best way of to learn, actually. Whenever you want to learn things, always take a real life scenarios, right? When we talk about the reinforcement learning is like basically learning from the mistakes. Like I usually use this term for this reinforcement learning, right? For example, you might have you maybe you can think of a car, right? Like for example, and what it does is it actually go and hits a ball, and then it tries to come back, right? And then it tries to find another path. So it is like a reward and a penalty kind of a approach, where if you are using the right path, you are getting rewarded +1. If you are hitting any object, you are actually getting -1 as a penalty, right? So this is kind of a reinforcement learning, where actually it's like a reward and penalty based approach, where you actually learn from the basically mistakes, like right, like self-driving car, game AIs, robotics. These are kind of comes under the reinforcement learning, right? So this is a brief about machine learnings. Once we have more sessions on this, we'll further divide these sessions and get deep dive into it, right? Let's talk about the deep learning. What is deep learning? A deep learning is a subset of machine learning using neural networks with many layers to recognize complex pattern, right? It's like a branch of machine learning that uses artificial neural networks, right, inspired by the human brains. These networks here high level patterns from raw data. Basically, these networks learn from high level data, right? High level data such as images, text, audios, and videos, right? And then actually propose those results. So as it is already mentioned, the neural networks with multiple layers of complex pattern recognitions. There are majorly three types of uh, key architectures. There are more, right? For even like I mentioned, CNN, RNN, transformers, but there are also autoencoders, generative adversarial network, GAN that we say, diffusion models, right? There are many, but like the popular one is that we use is three, right? Like just couple of what is like start just a brief about CNN. Yeah, you might have noticed like CNN is actually the neural network that is excellent for images, videos, and spatial informations, right? Like when you might have noticed that what kind of example, like when it comes to like image recognitions, video detection, like object detections in videos, right? Like in these kind of places, like where it is about identifying the edges, right? Corners, lines, colors, shapes, patterns, textures, right? Identifying the high level features like animals, cars, tumors, objects. Like medical science is one of the most active users of CNN network, right? So this is basically for identifying. This is very popular in identifying the objects, right? Especially when, let me give you one of the examples. Like when you do a CT scan, right, or MRI scans. Like of course, CNN is one of the popular examples of those used in that, right? Moving towards the second one, that is a recurrent neural networks. Recurrent neural networks is more basically it's more like identifying um, a sequence, basically like best for sequence, text, speech, time series data, anything where the order matters. The right statement is RNN is best for the places where the order of the data matters, right? RNN are type of neural networks designed to process sequential data where each step depends on the previous one, right? That is very important, right? So, like for example, like I can just give you a brief. I know it's a endless, it's a very big topic, but I will just give you how, at a high level, how it works. RNN actually reads its current item and it keeps it in memory, right? And it updates a hidden state and it predicts the next output. So this is basically it's about the sequential data, maintaining it. So it is always like time series data, like basically for text predictions, right? So these are the places that it is actually good, like basically understanding the messages, like chatbot, like when we say that, okay, when you, sometimes you might have noticed when you write you are hit by, automatically multiple options comes up, right? Car, truck, and all these things. So this is kind of here you are actually using the RNN network, RNN neural network, right? So when it comes to predictions, like generating responses, maintaining conversation context, right? So this is how we are actually. This is a context of using RNN, right? And going towards the transformers, right? That is one of the most popular popular, right? The architecture behind modern LLMs excel at language, vision, and multimodal AI, right? So when we talk about like as I said, I know transformer architecture is one of the most complicated one. So we won't I won't try to get more in depth because it will, otherwise the next 30 minutes or many hours will go away in within a second. So I will just give you a brief about a transformer, right? A transformer are the big breakthrough architecture that powers the today's smartest AI systems, right? One of the things that I mentioned in CNN and RNN is, in CNN, we are identified based on in CNN networks, what we do. We are identifying the objects like objects based on the corners, shapes, detections, right? In RNN, we are doing a sequential, right? By identifying the sequence through the sequence of words, right? But when it comes to the transformers, it is actually a combination of both. It's an upgraded version, right? So, for example, like it actually tries to parallelly identify the word. Means the transformer analyzes the entire sentence all at once, right? That makes it much faster, easier to train, and able to handle long text. When it comes to RNN, the one of the drawback of RNN is when you give a very long data sets, it that is one of the drawbacks of RNN, that it cannot handle a very long context, because it still have to keep the previous context. But when it comes to transformer based architectures, it can, since it is going like do it like basically traversing the entire sentence all at once, so that makes it much more faster. Like it's more like a parallel processing, you can say that in terminologies, right? So this is one of the, like, of course there are different ways of like transformer architectures, like self-attention, allow models to weigh importance of different words in context, feed forward network, multi-headed attention, right? I would like to emphasize on like multi-headed attention, where we actually basically this is called a running in parallel, right? Each attention head learns in different type of relationships. So self-attention is basically allowing the model to weigh the importance of different words in context. So maybe I can take an example. The dog that chased the cat was tired, right? The dog, if I say the dog that chased the cat was tired, basically the was tired is getting tied to dog, and cat is and chase is getting tied to cat, right? So it's a very small example, but it is very confusing. But a self-attention mechanisms is able to identify the weights, the importance, and able to connect. And through the multi-headed attention, we can actually develop a relationship between them, right? And of course, the position encoding is one of the important things. Capture the words order and sequence information. Residual is basically enables training of every deep network. Residual is basically like when you're actually like residual connections let the model pass information through the layers without losing it, right? So these are the some of the basically it's like preserving the important information in residual connections, right? So so as like I won't get very deep into it because it's a very massive topic, right? But that's it's very important to understand, like whenever you're using these LLMs or anything, what are these, right? What are the basics of these, right? So till this slide, actually, do you have any queries so far? Because after that, I will go to the RAG and vector, that is like consumers of LLM. Any questions so far? I understand it's one of the most like it could be happening and one of the most boring topics, but it is actually like a very important foundation of this artificial intelligence, right? Yeah, it's hard to understand. Yes, I totally understand, Shushal. Yeah, but of course, definitely, like I always, as I say, like if you are able to understand at a high level, if you're using something, right, you can use it in a better way if you know at least at a high level what it is. I always believe in that, right? That's why I always start with a very basics, that okay, and then we can always jump into the other slides that is more, you can easily understand these things, right? Maybe I will immediately move towards these are the very better topics that is easy to. Yes, definitely. We'll have a definitely fundamental sessions, and because I would like to split these sessions so that based on a people's interest, we can actually divide that, right? Yeah, I love to actually, right? I have a question about the cloud vendor AI/ML certifications. Where the worth or would be time better served during the project? Yeah, it was worth actually. I loved it, but you need to be very consistent, right? Uh, where it would time be better served during doing a project? Yes. When it comes to certifications, certifications give you a path actually of learning, right? And I did multiple certifications. What it actually, it's a kind of motivation as well. Sometimes there's a particular path, but it is very important that you are actually using those elements that you are learning into your actual projects as well. What I did is, everything I used to learn during the journey of the certification, I used to apply it in my current projects as well. So in this way, it is easy to remember, because sometimes the curriculum is so wide for these certifications that you will forget. One week you will learn something, and in the next third, fourth week you will forget. That's what usually, that's a tendency. So you need to keep on applying it into your real project, especially if you're learning, if you're working professional, right? It is very hard, right, to cope up, because you spend 8 9 hours in the office, and then you come back, and then you try to apply, you work. At least you need 2 or 3 hours on a daily basis of practice learning new things. So try to be consistent and try to apply whatever you are learning during this certification in your projects or in your current projects as well. Does it answer your question? Info set. I can give you some of the links as well. Yeah, I can give you some of the links as well, from where I was able to learn and able to clear those certifications. So yeah, so that I think that will be helpful for you guys, right? Okay. So coming back to the slide, right? Like, even so, usually, like, the best one of the best ways is that, no, not everyone wants to create the LLM, right? Not everyone, because it takes a time, right? One of the best of options that you have is basically use the existing LLMs and train it as per you, right? So, like, in LLM training process, basically you already have a trained data, right? And then you are training, it on top of it. I was using one of the, like, a speech recognition project. So I took the corpus of the data, a trained model, and I trained it as per my use cases. So that was easiest and quicker, and can get the product productionized faster, right? So always, what I believe, unless you are very passionate, don't spend much time in creating the LLMs. I did that. I created some LLMs out of curiosity, and I know that some of the LLMs took more than 7 8 months at least, and till 1 year, to get to a matured state to be productionized, right? And it's a very, you need at least lots of data sets, right? Yes, I will. Right. The RAG is the next slide. No, so fine tuning is, you are actually, there are two ways actually, Faisal, right? You are actually training the data. So when you come fine tuning the model is one thing, and using it in the RAG is a different thing. Fine tuning a model is, already have a data, already have a model that is designed, or that is trained on some defined data sets, right? Now you are upgrading that model in order to have your data sets as well, so that you don't have that you don't have to, like, upgrade, so that you don't have to actually put the data, because for example, if I'm writing a model for a financial institutions, right? And it is basically going to cater the bankers. I took one of the model, I upgraded that model, I trained that model further on its own data sets, and then consumed it. But in a RAG, that is retrieval augmented generation, what model you have already trained, plus you are actually, whatever you have in your vector database, the live database, right, from your information, right? You are actually using them both together in order, and then sending it to LLM. Are you getting the question? Are you getting? Hello? So think in this way, right? So we'll come to the RAG systems actually a bit more, right? So train on massive text corpus data, right? So it's like, just to further, one second, let me change the slide. right? So so yeah, so we'll come to that question. Phil, when see I go to the RAG, you will come to know further that what is actually the actual difference when it comes to like this. So let me go to this. Like large language model, that is, we are talking about the neural networks trained on massive text data sets to understand and generate human-like text, right? Key capabilities: natural language understanding, text generations, translations, summarizations, code generations. So most of the time, we are actually using these data sets in order to understand, generate some text transformations, question and answers, code generations, translations. These are the major things we are using LLM, right? And these are the popular LLMs for this. Like, yeah, there are many more now, but these are the ones, right? Now, so now coming back to one of the questions that person asked, that actually now you will understand the actual difference between training an LLM and actually what is a RAG, right? So when it comes to training, basically, so whenever you want to update a knowledge base, what do you do in a model, right? In training a model, it is actually you're retraining it again on top of your data, right? Right. Basically, you're getting inside those model parameters and then trying to update, add the data and put the parameters together, right? Because whenever you are training a particular model, you need to use the same set of parameters and then update that data, basically insert it, tune it as per your requirement. So that is more like fine tuning your model, right? Basically, you are inserting new patterns in the same model data sets, right? And tuning it, right? But when it comes to the RAG, right, you're actually not you're actually not tuning it, is you're actually basically using the retrieval context, right? Basically, you're that is outside the model we are talking about. We are not training a model. This data is something that is outside the vector database, right? This is where this your vector database, you're basically saving all the data inside your vector databases, and then you are using this for basically it is more instant, right? This is because you have saved the data, you are able to retrieve the documents, and then you can actually then you can use the trained model against it, and then you can send it, then use it to generate your text. So there you and that is a difference that becomes between, that is more. So what I say is, like, when it comes to vector databases in RAG, they are more instant. That is a better word, right? But when it comes to the tuning a model, it is more, of course, that is more expensive because you are actually trying to train the existing models and as per you, so that to right. But yeah, so that is one of the like major differences, right, in this. Further, when it comes to how embedding works, so this is just a brief about it, right? For example, you have like any text, right? If I go jump to the slide, this particular slide, you have certain documents, right? You convert it into embeddings, like, and then you actually store this store in vector database for the semantic search, right? So there are different databases. So whatever, so you can think of it like a LLM that doesn't have their own mind, right? It doesn't remember. Cannot remember everything. It is already trained on certain data sets, but it cannot. Yeah, right. But the point is, it also needs a separate hard disk to store lots of data, right? Like, it cannot remember everything. So here the vector database comes into picture. That is an external memory for a LLM. It works as external memory for a LLM, where we are storing the documents into the form of embeddings, right? We are converting that into the vectorization, vector data, right? So that's what when you might have heard about 760, 50 dimensions, right? 1500 dimensions and all these things. If you go to the PG vector, you can actually use the PG vector extensions, ChromaDB, Pinecon, right? Where you are storing those data. And then, so you're giving the LLM their like data in order to process, right? So one of the good examples, I will use this, right? When we say what are benefit, when we actually send any query, right? Whenever we send any query, it converts this into a vector, converts this query into vector representation, and find most relevant document for the vector DB. So what it's doing is, let me give you a quick understanding of this. Let me know when my screen is visible. There's an entire slide for vector databases. We'd like to go into advanced search, right? So this is what is happening is whenever you are actually saving the data into a vector database, it is actually putting the similar items together, right? And then when you are actually searching this, right? Let me show you. When you're actually converting this embeddings, whenever you're converting the query, the prompt that you say into a embeddings, then it compares that. It's trying to search the closest match again in the vector database and try to give you the results. When you say top K results and all, right? This is actually, we talk about top K results, right? Embeddings, and then it searches this in a similar document, and then it returns some set of data. When we say top 3 results, top 5 results, then it returns those top 3 results or top 4, whatever you mentioned. Take that data. That is a part of retrieval. So retrieval is a part of this. We are retrieving the data from the vector database. First of all, you save the data into a vector database, your documents, acts like a memory. When we talk about the query, you convert this query into a vector, then you search this vector into vector database. That is a kind of when you're sending this query and the data that you have retrieved, the top 3 or top 4 data sets that is closest to your query, when you retrieve that and put together, that's called augmentation. Basically, you're augmenting, you're enriching your query with the relevant data sets so that your LLM knows where to find the results. It may have its own, some of its data, but you know your data, but you have your own domain, you have your own domain expert database from which you are retrieving the top 3 results or 4 results based on your query. And then you are telling your LLM, boss, this is my query, this is my prompt, and this is a relevant data that is close to this query. And then now it's your job is to create, based what I'm asking you, to get the answers, summarize, translations and all. This is your job, boss. So this will actually, so that vector database works as an external memory for the LLM in that case, right? Combines the power of vector search with LLM generation to provide the accurate contextual answer grounded in your data, right? One of the most popular thing that you might have heard about is hallucinations, right? My data, I'm getting too many hallucinations. I don't know what LLM is responding. I don't understand. You might have faced these issues when it comes to the chatbots on production or when you're testing, right? Why these things happens? Because you're not providing a proper context to the LLM, and that's why the better you actually, when you're searching it, you need to make sure that when you're getting the data retrieving from the vector, it needs to be very, very closest to your context, so that LLM can use it in order to generate the proper responses. Yes, there are certain parameters we'll discuss in some of the sessions, that how to tune your LLM. But at the same time, it is also important that you also provide its relevant data sets in order to generate the response on top of it, right? These two important, these are, you cannot always blame the people. I've seen people like, okay, the LLM is not good. It's not always about LLM. It's about, are you providing it with the relevant data sets in order to provide the response that you are asking? That is another question, right? And also whether that LLM is actually trained for that particular activity that you are asking. So that is another topic that I will take up, that when do you, for which use case you need to use which type of LLM, right? So coming back to the original slide, that's what we have, like augmenting combined query with the retrieve context, and then finally LLM creates the accurate and context aware responses, right? Let me know if you have any queries. I'm trying to make it more as like understandable as possible, right? But please feel free to ask any questions, right? When we talk about the embedding models, right? There are different type of embedding models, right? OpenAI embedding 3, right? Sentence transformers, Google universal sentences, right? And these are different dimensions we have, right? Usually, like, you can use, I sometimes I suggest that, okay, you can use Olama, like the different embedding models, and maybe like any freely available model that is best nearest to your use case, right? How many dimensions you have, this is something you need to decide based on your use case, right? Some of them doesn't require such a high configurations, high set of parameters. Your work can be done with a smaller set of dimensions, and sometimes you really need a high dimensions. So basically, the lower the dimension is, the lower the computation cost, but the chances of hallucinations might be more. But the higher the dimension is, the computation cost must be higher, but there's always a possibility of you getting a better results because you have more parameters, you have more dimensions in order to do those semantic search. But there's no fixed rule. It is a very, very high level general rule, but it is always vary based on the use cases. Sometimes at a very low dimensions, your data accuracy is high because your data set doesn't have that many of attributes in order to go towards those number of dimensions, right? So always think that what is your use case rather than going with just what Google is or Chat GPT is suggesting. Try to think that, okay, what your use case is up to, right? You can always share use case. I can always try best of my knowledge to share that, okay, what could be the best dimensions and models to use in order to productionize these kind of applications, right? These are some of them: vector similarity, distance matrix, cosine, like Euclidean dot products. These, when you some of the so like when you actually go using chroma db or sometimes pg vector, you have an option to provide that what kind of semantic search you want to make, right? So let's say a critical agent app. Critical agent means like particularly for which use case, like what you're trying, what type of exactly what agent it do. Uh, can you in just one line? What is the use? What for which particular domain and what you are actually what is what that agent is do? Like, can you specify that? A baking, right? Let's say a baking. So baking, basically, you're talking about the chef agent, if I'm not wrong. Oh, banking. Sorry, my bad. I just that right. So banking is a very huge one, right? Uh, right. Banking is a very huge domain, right? In bank, yeah, accounts opening, right? Okay, let's talk about the accounts opening, right? In accounts opening, there could be, if you whenever you open an account, right? Yes, the recording will be shared. Yes, definitely. When we talk about the account, when we talk about the account, when we talk about the account opening, whatever different parameters you are that important, your credit score, correct? Your KYC, your how many accounts you want to open, what is the initial, what type of account is it? It is a savings, checkings account, and what is the minimum balance needs to be maintained? Do you have any fraud detect? Do you have any previous history of right? What are the different services you are enrolling for based on your companies or your individual turnovers, right? What is amount? What is your credibility? What is your paying limit? These are different parameters we are talking about, right? Based on that, you can, like, these are some of them because I've worked on one of the account opening project, right? Right. So these are just some of the parameters that we use, and also the assignee, signers, physical documents, right? Who are the signers? Whether like what's your right, annual salary, or if you are individual, if you're a business, whether you're small business, mid-sized business, upper size business, all these parameters comes into picture, right? Now, based on that, if you can actually take up one LLM model that is very closest to you, I can suggest some of them, like, and then you can actually, based on these parameters, what are the parameters that is important to you, right? Now, there could be thousands of parameters, but you are correct, but your parameters you are bothered is only 7 to 8 that maybe what I mentioned. Now, based on that, you are actually trading off when you are actually querying it, when you are actually asking your chatbot to do some transaction on Amazon, for example, right? You're asking it to take some actions, right? It goes and check, right? So that in order to provide it an accurate response, you need to make sure that your model, whatever you are using, should be tuned enough for your use case, for your account openings, considering all the parameters, right? And then accordingly, and your vector search, you need to be like the so that you can actually search for those. And another important part is using the metadata, right? You need to start categorizing those data, labeling those data, so that your search gets more and more narrowed down as per your query. So if I'm actually, you can automatically label your query as well. then so for example, if you have 5 billion of data sets, right, it will, and you have already categorized it, it automatically comes down to very fewer. And then you can actually further use the temperatures and more like context tunings in order to further reduce the hallucination as much as possible. Always think in this way: your LLM cannot be 100% possible, right? It is not possible that your LLM will always be 100% true. There's no LLM on this globe that exists on this earth that could get that it will assure you 100% accurate response. You always gradually, with your trained data sets and your external memory, that is a vector database, and your parameters, making it more tuned, you increase its accuracy, right? And the configurations. I will send you the configurations that you can use in order to train your LLMs, right? Moving on to the different vector indexing search. So I will just quickly go through that. Hierarchical navigations, inverted. So these are one of the things as well that you need to be ensure that you're properly indexed. Otherwise, your performance will start degrading when it comes to higher data sets. So these are, so I will share the slides as well. Moving to the advanced search, actually, hybrid search, contextual compressions, re-ranking, multi-hop reasoning, self-RAG. These are some of them, but before that, I suggest always use to start create a small agentics before you actually go into those advanced RAG patterns, like combining semantics and keyword searches. One of the search mentioned, I use combining metadata as well as the semantic and contextual searches. Generate multiple query variations to improve retrieval. So you can convert your query into the prompt into your query in order to go to the no GraphQLs or maybe the SQLs or NoSQL databases. Model decides when to retrieve and evaluate retrieved documents. So there are multiple ways as well. So we can get deep dive into individuals. When it comes to the prompt engineering, that it is more like when you're interacting with the prompt that, okay, what is the different techniques, right? So this is a very dedicated presentation I have for prompt engineering. You can actually go through this. I can just quickly show you. Right. So these are simple prompt. There are different ways. It is available on the site, right? That prompt, what a prompt, how to make sure that prompt is good enough, right? That is also quite important, right? So is the process of creating prompt, the desired responses you get. So there are different type of prompting techniques actually. So you can already, there's already a slide on it. You can possibly go through it. And there's also a mention of Aristotle 4 cases applied onto AI prompt, right? So you can possibly go through it in order to make sure how the prompts are better, right? So clear and specific instruction. A few shots means you're giving them multiple examples so that they can take a better decision. You can get a better responses. Chain of thoughts, reasoning. You're actually telling that, okay, this is a scenario, and you can the input or output of something that gets input of something else, right? You're giving it different criterias, right? One of the important things that I would like to mention is that quickly, right? The Google, this came from components of prompt, right? Just to quickly, task required, right? So it is critical to add metadata when saving embeddings into, without a metadata, query results still be correct. Yes, without metadata, this query results still be correct. Yes, it is possible, definitely. But at the same time, think in this way: when you, so depends upon your data sets and how versatile your data set is. If you know your entire data set is related to account opening, then definitely there's a possibility you may not use it. Account opening has multiple variations as well, whether it's a business account opening, whether it's an individual account opening, whether it's for NGO, right? You need to be very sure, because accordingly sometimes the rules and regulations gets changed. So yes, metadata helps you to narrow down your semantic searches before it gets into the semantic search. So that will actually improve your performance and reduce the hallucinations. So yes, in a way it is important, but at the same time, if your data set is very, very specific to the use case, and you know there's never going to be variations and there's not versatile data sets, then definitely metadata is not right. Kind of indexing, yes, it's a detailed topic. I will definitely you can actually go through this. Let me show you quickly. So there are different type of indexings, right? You can possibly use any of them, right? I will actually share a detailed presentation possibly on indexing, so that what kind of data and how which kind can be indexed, right? Yes, indexing is important to improve the performance, definitely. For the performance point of view, yes, it is, right? But as I said, like David, we'll give you more detail onto this because we have like a couple of minutes left, right? If you can send me your use case as well, so I can tell you that what kind of indexing is important and what kind of indexing you use, right? Right. So, more like one of the real world applications, as I mentioned, customer support, documents, code, assistant, semantic search, right? These are one of the platforms that we use, LangChains, Llama Index, Hashtag. So I really suggest to go with LangChain first. Maybe start with a very small vector. We'll have the workshops as well in next couple of in every week, so you can join that. It will be there on the like our site, AI DevWorks. So the presentation will be present. Presentation recording both will be available. Right. Right. These are some of the fundamentals like using Pythons. We'll be having a Python sessions as well. Some of it like every week we are planning to, right? And then building our OpenAI, using Olama, building RAG-based applications, moving to productions. So we'll actually guide you from scratch till productionizing the application so that you can get very confident when you're developing any kind of a intelligent systems, I prefer to say, right? They're just moving towards AI development best practices that you can easily get. Testing and evaluations, cost optimization, security, ethical AIs, right? So one of the things is that, like when it comes to indexings and all these performance related, this is kind of comes under the cost optimizations, right? Because everything cost is not about always money. It's about costing of the performance. Cost is could be anything, right? So you need to keep in mind, like it's not always, even you may have a millions, right? But the point is, if your performance is performing bad, then it's gone, right? Ethicals, you might have heard about lots of news that, okay, zero trust architectures. I will share one of my article that I've written on zero trust architectures, ethics, right? Human oversight of critical decisions. um, there was a news where one of the AI has taken decision and the whole data company data has gone. It actually deleted the entire company data. It was in the news like few some time back, you might have heard, right? So if your AI is capable of taking a proper actions, right, then you need to ensure that it is, like, you need to ensure it is mapped to proper actions. And there should be different levels of hierarchy, right, in proper maintaining. Like, for example, a make a checker process needs to be there in order to ensure that your particular LLM should not take any decision that is going to hamper your data. So these are things that you need to learn. Yes, for a technical project manager, we'll come to that, right? Suresh, for a technical project manager, we'll share that part. The thing is that for a technical program manager, sorry, it is important that you should understand the terminologies of this. It is not important that you should get into deep dive of it, because for a program manager it is not required, what I believe. But for a program, for as a so but whatever the terminologies that I'm mentioning, right, especially these kind of things, Suresh, let's talk about this particular slide: cost optimizations, ethical AI, security and privacies, test evaluations, right? I will share the path as well, a detailed path of different domains, different domain experts, I mean, different technocrats. But this is very important slide for you, Suresh, if you are just looking for the technical project program manager point of view, right? At a high level, because these are the areas you need to be good in it, right? Uh, like resource optimizations, cost, ethics, securities, taking the data, what type of AI. So there will be, I will share one presentation where maybe we'll schedule some session where what type of LLM needs to be used in for what type of data sets. You may not, as a program manager, you may not have to need to know that how it is going to execute it, but you need to have it right. You need to you should be able to take a decision that when to take what type of LLM. So that is also quite important for as a technical project manager, program manager, right? And because you might be handling multiple portfolios of AI, right? Possibly, right? But I will share that. Does it answer your question, Suresh? Uh, but yeah, we'll share the more detailed part. This is also one of the important things for everyone to know. That is, what are the challenges, hallucinations I meant about, computational cost, latencies, model interpretability, so society challenges, biasness, So this is another thing, Suresh, that you need to keep in mind, like as a program manager, whosoever is it, that this is also technical. What are the different challenges and societal challenges, right? So these are also things, right? We'll share those slides. You can possibly go through that. The future of AI, we already know that it's going like hell, right? We basically we have multimodal AI agents are taking up lots of things. We have Devin AI as well, who is actually many financial institutions are taking up in order to replace some of the one of the high, that. So basically, like especially when it comes to the future of AI, like people are trying to add AI resources as well in order to do their job as well, right? So you need to understand how to use AI for sure in order to survive in the current arena. It's not always required. It's your, for example, I might be interested in developing the AIs, LLMs, but the people I there who are interested in actually using the AIs, right? And in this community, we are catering different type of users who are the consumers, who are the just want to know at a high level, or maybe who want to deep dive. So we'll categorize the sessions based on the interest, and so that everyone's interest get catered in this entire community, right? Learning resources. If you go to the AI DevWorks side, this is a resources side, right? So this, as I said, by the end of next sometime next month, you will see it will rise up to 1,000, right? So please go and play around with this. So it has like basic learning resources till actually the research papers as well. So you will find lots of things over here, right? So this is actually the kind of thing, beginners project like personal chatbots, text summarization, sentiment analysis, right? And when it comes to advanced projects, custom fuel to production RAG pipelines, right? AI-powered analytics as well, intermediate projects, community projects. So we have different type of projects, and we'll be working with different type of consumers in this community in order to groom them for different type of projects, right? And right, and this is kind of upcoming workshops, like you will be building your own first rack applications if it is new, vector database deep dive, prompt engineering master classes, production AI systems. There will be group projects as well, like research paper, code reviews, study group matches. So all things we are going to come as we are moving towards as well, actually, towards the community, right? So this is actually the complete, if you see that what we are discussing entire at a very high level, putting together, right? User applications, API layers, vector database, LLM, and this data source, right? So this is a data user application, then it's API layer, it comes to that, it searches for the vector data, embeddings, and then it goes sends it to LLM, right? Maybe like the vector database, of course, this could be a data source that gets onboarded here in vector database, right? Not you don't have to onboard, it depends upon your use case. In one of the financial project, like I was actually dealing with the Salesforce data, right? And we don't have to onboard all the sales because we have more than 100 GB of Salesforce data, right? In that institution. And what I did is ended up in that we created our references to the Salesforce rather than saving the entire Salesforce data into a vector database. Some of the information got saved, but not all of them. So in this way, we can actually, it depends on your use cases and how and what are your plans and what are your current and future plans. So we can discuss them individually as well, right? This is a stack application layer. So we already discussed this. We already discussed user ask questions. So I'm just right. So this is all about this community. Actually, we are planning, but we also do want to expand. Our currently, I was assigned to the Gen AI team, so who creates different chatbots. Oh, that's nice. Actually, if you want to discuss any particular use case and all, I'm happy to please share your use case, right? And I'm happy to share my inputs as well if you need any time, right? And apart from that, like this majorly, of course, we started with the artificial intelligence community, but we are also we want to expand at different tech domains, trying to make the systems intelligent. So our goal is to create the intelligent systems creating a research and development community. So will gradually move into we are actually will target that goal to enhance it, right? We having our own blogs as well very soon in Q1, and maybe I can show you one of our newsletter as well that we are actually planning to. We have actually have this. Let me know. So this is our own newsletter. That's a weekly newsletter that will have the news and all. So that is also we have recently launched actually in this December. So we'll be sharing across. So you'll always try to get the latest updates of that AI, and also you can also in the same newsletter, if you'd like to present your project, we are happy to add it, right? So maybe your inputs. So yeah, we'll have those sections, right? We're also planning to launch our own magazine. That is a quarterly magazines as well, e-magazine. So we have like multiple plans in order to take this community to a entire next level, right? A typical like intelligence system based communities, right? So this is for all from my side for now. We already exceeded 12 minutes, but I'm happy to answer if you have any questions. I try to answer in between. So let me know if you have any questions. Please go ahead. The platform is open for if you like to discuss anything. Uh, you can raise your hand if you like to. I can just unmute you. Any questions so far? We'll put that in a AI DevWorks actually, as well as we'll post in our meetup group. We also have we recently launched a Discord group as well. We'll share that link as well. And yeah, so we'll definitely post in a meetup group. It will be part of AI DevWorks community site as well. So yeah, so you can actually have this weekly one, right? Yeah, thank you so much for I know that was lots of information, but it was just giving you a high level picture that how we are going to move forward and with this community, and we have lots of exciting things to do in this entire community. We have many research scientists who have already joined this community, so they will be taking up the sessions that they have written. The next session will be next week. Yeah, then next, so what we are trying to do is like we'll at least once in 15 days for sure, but at least we'll try to make it every week. But like at least in 15 days, you'll always have something, right? Yes, all the sites will be available. You just visit this AI, this site, AI DevWorks site, and you will find that. Let me show you as well. So if you go to this particular site, right, and if you go to the past meetups, you will see all this. So they're both type of slides. There's PDF and as well as that HTML as well. So if you see that this is like a view and this is like a downloadable. So you have both options are there. And slowly there will be a recording section as well that will so that you can also access the recordings of the discussions. Right. Yeah, I'm happy to. And please, anyone like to? I actually rolled out one form. Right. Anyone who would like to present it, please. I'm happy to have him. Right. And of course, once we are also starting a Python project, Python sessions as well. So yeah, any particular or different type of requirements you have, and we have a set of people, right? Then we are happy to cater it based on its like everyone's feasibility. But yeah, thank you so much. Right, looking forward like enhancing this community together and learning together. Yeah, yeah. Thanks so much. Please reach out to me if you have any questions. Yeah, thank you once again. Thank you.
Thank you. Bye.
Thank you. Bye.